Okay, next up we have Immanuel Haffner from Saarland.
Thank you. Hello, everyone, and thanks for having me here at CIDR. My name is Immanuel Haffner. I'm a PhD student of the Dittrich from Saarland University. And today, I would like to talk to you about a database system we started developing. It's called Mutable, and it's a modern database management system for research and fast prototyping. And a more honest title would be Towards a Modern DBMS, because this is work in progress. So assume that you are a researcher or PhD student working in the domain of database management systems, and you have some bright idea that you want to evaluate, want to experiment with it. So what you can do is you can just start from scratch and implement what you need. This is a lot of work. So you might want to use a database management system off the shelf. And what you can do is you can go to the database of databases, and there you can search for a system that suits your needs. So at the moment, it lists a whooping amount of 877 database systems. And this is promising. You could say, I will certainly find a system that suits me. However, now because we're doing research, we might be looking for systems that are in the academic or educational domain, and we are working on a relational data model. And suddenly there are only 34 systems remaining, but worry not. In this list, we find popular open source projects like PostgreSQL, DuckDB, and NoisePage. However, what if we're actually working on code generation? So we add this to our search, and suddenly there are only 2 systems remaining, namely NoisePage, which is an open source system, and Umbra, which is closed source. And so in this particular scenario, we would be stuck with NoisePage, which isn't a bad thing, but there's not much selection that we have.
We also killed it, so you don't want it.
Yeah, I've seen it. The last commit was like 2020.
Yeah.
Yeah. Anyways, it's there. It's available, right? So what is the status quo of open source DBMSs? And in brief, one could sum this up that PostgreSQL is remaining the top dog. It has been there for decades, and many research is still flowing into the system. However, it's old and a bit outdated. So there are nowadays some emerging systems that bring state-of-the-art technologies to the open source, like, for example, DuckDB, and there was NoisePage. However, there's still much research that remains proprietary or closed source. Consider, for example, Haffner and Umbra. So from my point of view, I have a subjective problem, and that is it's difficult for researchers and developers to get started with the available open source projects. And I have 2 reasons for that. One is the lack of documentation, and the other is there are many built-in assumptions or design choices in these systems. And let me explain this. When I say there's a lack of documentation, I don't mean that these systems won't provide documentation. So if you consider Postgre, there's a lot of documentation on the website, for example. However, this documentation is targeted towards database administrators or database users. As a developer, it's harder to get started. When you consider NoisePage on the other side, they did a great job in documenting their design decisions in these Markdown files, which are part of the repository, and you can read this up. But these design decisions were taken, and whether you like it or not, if you want to use the system, you're stuck with these decisions. So our vision is to build a new system, a system that is primarily targeted at researchers and developers. So it's not a system you want to use in production. And the system that may serve as a unifying framework for database research so that it combines many different approaches and you have them ready at hand to evaluate them and compare your idea to these existing solutions. Also a system that imposes as few design decisions on the developer as possible, so it should be flexible such that your research idea can fit into the system. It should be flexible and configurable to the developer's demands. So for example, a developer may not care about join ordering, so you can just opt that out. And of course, we must provide documentation that is targeted towards developers and that this is onboarding for these people. So what is our approach? And now let's just assume that we want to build a new database system from scratch. So we have to think of many, many things. So we have to think about data layers, storage, cardinality estimation, cost functions, then enumeration, or I call it join ordering, but just some mechanism of coming up with various plans for a query. Then query execution, for example, interpretation versus compilation. And there are other things not listed here, like concurrency control or indexing. So all of these things, these entities have to be united in the system, and this is what Mutable is supposed to do. And we call these entities on the outside the components of the system. And these should be replaceable. So what are our design goals, our software design goals with Mutable? We want it to be extensible. So let us consider the particular case of plan enumeration or join ordering. There are various algorithms to solve this problem. There are the dynamic programming algorithms, the size sub CCP, and the top-down, also dynamic programming kind of algorithms like min-cut, advanced generated test, or the mixed branch, and there are some other algorithms, of course. So now, if you want to do research in this domain, what you should do is you extend the system, however the system Mutable, by just providing a new implementation of that particular component. And hopefully you need not touch anything else of the system, and you don't need to be aware of anything else of the system. Of course, our design goal also means we have to provide proper documentation of these components such that people are actually able to do this implementation, and our API must design in such a fashion that your research idea can be fitted into this API. Our second design goal is the separation of concerns, and let's again consider the case of plan enumeration. So when you will enumerate these plans, you have to account for the intermediate results that are part of your plan, so you need the cardinality estimation component. And it's very legit for the plan enumeration component to query this cardinality estimation component to get these cardinality estimates. So this cardinality estimation component may be implemented in various ways. For example, you might use histograms or some more fancy tool like a sum product network or some other way. Now, what's very important is that we make sure that the implementation of the plan enumeration component does not depend on a particular implementation of the cardinality estimation component. If that would be the case, you would violate the separation of concerns, right? And you could just not just simply plug in an alternative cardinality estimator because suddenly the plan enumeration would break. And for a developer, this means he or she must only have knowledge of the API of other components and must not be concerned with more details of these other components. We also add one more particular constraint here, and that is in Mutable, the components must appear stateless to the outside. And what this means, I'll explain in a few slides. Our third design goal is abstraction, and you could argue, of course, yeah, every larger software project needs abstraction, sure. What we mean in particular here is this abstraction must adhere to the nomenclature that we are using in the database community, easy onboarding for people in this domain. But also, this abstraction must support our previous claim of separation of concerns and also the statelessness. So if you look here at this plan enumerator component, this is like a virtual class. It has a virtual method. And this is the only thing that this interface provides. We have to implement this. And what you can see in the parameters of the function, we have this query graph, which you can consider like a semantic description of the query to run. Then we have the cardinality estimator and the cost function, which are other components that this component will be using. And we have a plan table, which may be initialized, shipping some initial values, but then it will be filled by this plan enumerator component and will be returned. And in this way, we clearly separate which are the values that go into the component, which are the other components that will be used by the system, and which are the values that flow out of this component. And through this API, this component will remain stateless. Yeah, you can see where it's going, where it's come out, and it's very legit for one component to make use of other components. Our fourth design goal is abstraction without regret. So what is the regret part? If you think of abstraction through dynamic dispatch, for example, virtual methods, they may be too much overhead in scenarios where a function is frequently called and only short running. And this is particularly true if you think of interpretation-based query execution, and it has led to development of techniques like vectorized interpretation. So code generation to the rescue. How can we get away with this regret? One way is we use template metaprogramming for compile time composition, and we let the compiler do the heavy lifting. However, this is not always possible, and in cases where it's not, we want to use code generation. But code generation is a tough part, particularly because we are database people, not compilers people. So what we do in Mutable is we develop a deeply embedded domain-specific language that mimics C in its semantics and syntax, and it makes it easy to adopt code generation. So how are we achieving this extensibility and separation of concerns part? And this evolves around a concept that is called the value is the boundary, that was advocated for by Gary Bernhardt at SCNA 2012. And it's a fantastic talk. I can really recommend it. It's about software design. But the essential takeaway message here from Mutable is that if you look at Mutable in the center with the components on the outside, then Mutable is the stateful part, contains all the information, the state, like the tables and the indexes and whatnot. And the components have to be stateless, and Mutable takes care of communicating this information back and forth between these components. So how do we achieve abstraction without regret? And I already teased this. So consider here, for example, a SQL query with a selection with a where clause for x greater than 42. So now we want to generate code for this because we cannot get away with template meta programming. So what we see here is the actual implementation in Mutable, and notice subtle difference to the regular C code. So here you see an uppercase if, and there's a semicolon at the closing brace. And we also invoke some compilation routine for the selection condition. So what executing this code actually does, it will generate WebAssembly code. This was our choice of compilation target. And yeah, so you see here we generate a conditional branch. These generate compiled condition, actually inverted because the branch will bypass the pipeline. So it's just a WebAssembly thing. So what do we do with this WebAssembly code? We submit it to V8. V8 puts JavaScript and WebAssembly engine, and it takes care of performing just-in-time compilation to, for example, x86. And it does so using tiered compilation and adaptive execution, and you can even go beyond that and use profile optimizations. Yeah, so what can Mutable offer at the time currently? So when you consider data layouts, we have built a generic framework to express arbitrary data layouts. And within this framework, we have implemented row layout and plugs there with varying block sizes. And what's kind of interesting, using this framework to describe how your layout is supposed to look like, and then the compiler, the query compilation picks this up and generates code that is just optimized for that particular layout. So looking at cardinality estimation, we have implemented some product networks which you can put into the domain of interpretable machine learning, and then using a neat trick, we can just tune them to behave like histograms. For cost functions, we have implemented cost function cout by Mercotte that we use for logical and algebraic join ordering. And we have also implemented a linear regression model that will be trained on automatic benchmark. So you can just run Mutable and say benchmark, and it will just run some benchmarks. It will train these linear regression models, and you can use them for selecting physical operators. For plan generation, we have implemented a wide range of different algorithms from the literature. And we also have recently developed an algorithm that's based on heuristic search, on which we also have a paper at Sigma 23. And here we are able, on the hard cases, to achieve speedups of factor 1000 or even more compared to state-of-the-art algorithms like DBMS. So now, considering the query execution component, we have implemented an interpreter, but this is discontinued because this was just really a bad idea, because this was like a VM based on stack machines, not a good thing. Anyways, then we have implemented WebAssembly and V8. So we compile to WebAssembly and we run it in V8, and we also have a paper on that at EDBT 23, where you can read more about that. In short, we are able to achieve JIT compilation, tiered compilation, and adaptive execution just by using V8 out of the box. Also, around Mutable, we have built a continuous benchmarking framework that runs the benchmarks every night. It reports the results, and it also runs not only our system, but other systems. So actually the WebAssembly things, these are ours. But we also run Hyper and DuckDB and PostgreSQL, not shown here because it's too slow, but we run them and we gather these results, and we have written a REST API that can query for these results, and we automatically detect performance anomalies. We can warn the developer of those performance anomalies, and we also can just, looking at the Git history, commit history, and we can find out the authors that may be responsible for these performance anomalies. So with that said, Mutable is now open source. We made it open source for CIDR. This is still a work in progress, so please keep that in mind. And also the shift to the open source domain, so from our initial GitLab now to GitHub, it's still in progress. But the code is available. You can follow the QR code or the link provided. And now I'm happy to answer your questions.